In this video, we'll talk about merge sort. Now basically, let's talk about the theory first and then we'll focus on the implementation. Now when we talk about sorting techniques, we have worked with multiple sorting technique, and when we talked about the quick sort, which was going for a time complexity of n log n, now we have one more there which is called a merge sort, which also has a time complexity of n log n. Now, both quicksort and merge sort follows a technique called divide and conquer. So basically what you do is, you break down the problem into subproblems and apply the algorithm on those particular subproblems. And once you get the solution for each subproblem, then you combine the solutions or sub-solutions to get a final solution. That's what we are going to do here, which is divide and conquer. Okay, so how we are going to do this? Now, basically, it is actually easier to understand. So if you can be with me, it will make much more sense. So what we're going to do is we'll take an array initially. Okay, so let's say I'm taking a list of values here. So let's say we are going for 6 values here. And what are these 6 values? So let's say I have a value which is 8, 5, 9, 1, 6, 7, let's say. So we got these values here, and then I want to sort them. So what you do is you will apply a merge sort. Now basically here, as I mentioned before, you will do 2 things. You will, in fact, 3 things. First, you will divide this problem into subproblems, and then you will conquer them, and then you will simply merge them. Now, since it is called a merge sort, the important step here is merging. So when I say important, I'm also saying it is complex part. The easier part is to break down this into small parts. Merging will be time consuming, so let's understand this. So when you have these values here, what you will do is, first of all, you will break down into 2 parts. Now the question is, how will you break it down? In different sorting algorithm, we have a different way of breaking the entire list. In fact, in quicksort, we use a pivot. But here, let's make it very simple. We use something called a median. Now, what is a median, or maybe a midpoint? So here what we can do is, as we know that if you talk about this particular array here, the mid is here, right? We can see and we can tell that. But how an algorithm will know that this is a mid? And that's why we will do some calculation. Now, what kind of calculation? It's very easy. So what we can do is, let's say this is your left and this is your right. So what we will do is we'll simply use index values. So the index values for this is 0, 1, 2, 3, 4, 5. So that depends upon the values you have. And then if you want to find a median, so basically L represents the first index value and R represents the last index value. So you have to find a median. And the formula for median is very simple. So what you will simply do is you will say median is equal to left plus right divided by 2. That's how you get the median, right? Now in this case, the median is, what is L? L is 0, R is 5, and this divided by 2 is equal to 5 by 2. Now since in different languages we get different outputs, so let's say this is 2 in this case, because in most of the languages we go for the float value. So we got 2 here. Now 2 is your median. So this is your median. So whatever is there on this side will go into a different array, and whatever is there in this side will go into a different array. So when I say array, I'm talking about the list. So what we can do is we can divide into 2 parts, and then we can create a different section. So we got a section here which has 3 values. We got a section here which get 3 values. And then the values will be 8, 5, 9 here, and 1, 6, 7 here. Okay, and again, the job is not done. Again, you have to divide into 2 parts. Now, how we are going to do that? It's very simple. The same steps which you have followed. Again, you will take L and R here, L and R here. Let's find the median of the first point here, or the first array. Now, how do you get the median? Again, you will say M is equal to L plus R divided by 2. So now we can do it quickly. So what is L in this case? So if you go with the index value is 0, 1, 2 in this case, and 3, 4, 5. Now if you talk about the first array, the L is 0, R is 2. So you will say 0 plus 2 is 2, and 2 divided by 2 is 1. So M for this is 1, so M is here. Now if you want to calculate for the next array or the next values, so again the same value. So what is L? L is 3, R is 5, so 3 plus 5 is 8, 8 divided by 2 is 4. So 4 is here, so median is here. Of course, when you look at the values, you will find the median just by looking at it. But let's talk about the algorithm, and we don't have a limited set of values. What if you have 500 values? You will not simply search for the median, right? So that's how we can get the median. Again, you will divide into 2 parts. So we can divide something like this. You will get 2 sections here for this, and 2 sections for this. We can say the first section will have 2 values, which is 8 and 5. The second section will have a value which is 9. Here the first section, since we only have one value here, 9, we got 9. But let's say here we got 1 and 6, and here we got 7. So basically that's how you divide. Again, the job is not done. So you have to go till the end. So what we're going to do, again, you will divide the first one. So can we divide the second one? The 9, we don't need to divide this part, right? Because when you get one value, you cannot divide that. So let's divide the first part here. So if you divide this, you will get again 2 values, which is 8 and 5. And again, you will divide this, you will get 2 values, which is 1 and 6. So that's how you can divide, and at the end you will get the individual values. Now still we can persist the index value because we are not physically dividing them, we are just virtually dividing it, right? So index value for this is 0, 1, 2, 3, 4, 5. The index number remains same, and if you compare with the actual list we got, the index value and the values are same, right? So till this point we have not done any sorting part, we just did the divide part. And now it's time for the conquer. Now, when you say conquer, it simply means that you need to sort this value. So whatever value you got at the end, sort them. But if you observe, they are already sorted because each element, if you compare, if you say 8, this list is sorted. When you have only one value, it is by default sorted. Okay. So sorting is done. So conquering is done basically. The next step is to merge them, and the actual fun starts here. Now, when you say merge, what it means? So basically what you do is you start with the first 2 values and then you merge them. Now merging is important. So when you say we are merging 8 and 5, of course you will get a list and you can again say 8 and 5, but no, this is not how you will merge it. So the way you will merge it is this. So you will take these 2 values and merge them into another block. You will get 2 values. But when you're merging it, you will compare these 2 values. So which is less here? So if 5 is less, you will put 5 here and then you will put 8 here because that's the only remaining element. Then you think about merging. So you will merge this 2. Now when you're merging this 2, of course you will get 3 values, right? So you will take 3 values here. And this is coming from here. So this 2 values and this 1 value. Now how will you merge? Now since we have 2 different lists or 2 different values here, or 2 different arrays we can say, when you want to merge, that's where the actual algorithm starts, because when you're merging 2 values, you can simply compare smaller or get greater. But now we have 3 values. In first we have 2, in second we have only 1. So what you do here is you basically compare these values before adding them. So what should be the first value? Now we know that the previous array is sorted, right? And then, in fact, both the values are sorted, both the arrays are sorted. When you combine them, what you can do is you can compare the first 2 values, only the first 2 values, not 8, only 5 and 9. So which is smaller? 5. So you will put 5 here. Now, since 5 is done, you can simply say, okay, I'm done with 5. Now let me focus on 8 and 9. So which is smaller? 8. And then the only thing remaining here is 9. So we'll put 9 here. Now that's done. Now let's combine this 3, which is 1, 6, and 7. Now first you have to combine this 2. So you will get another box here, which is 1 and 6. So we will compare. So it is 1 and 6 because they are sorted. So now we will combine the next part. You will get 3 values here. Now when you get 3 values, what we are doing is we are basically combining this section and this section. Same steps. You will compare the first 2 values. So 1 compared with 7. So 1 will come here. This is done. Then compare 6 and 7. 6 will come here. This is done. Then 7 will come here. Okay. And then now the major work starts. We have to combine this 2. Now when you're combining these 2, you will get a bigger array of 6 elements. So 1, 2, 3, 4, 5, 6. So we got 6 boxes. Now what you will do is you got 2 arrays, and we know that those 2 arrays are actually sorted. When you combine them, again you will start with the first 2 values. So when I say first 2 values, let's compare 5 and 1. So what you will do is you will compare, okay, 5 and 1, which will come here. So it is 1. So this is done. Then you compare 6 and 5 because 5 is still remaining, right? So 5 and 6, it is 5. Then 8 and 6, which is 6. So 5 done, 6 done. Then 8 and 7, so which is 7. So 7 done. Then 8 again. Now we don't have anything to compare from the next array. So you can simply take these 2 values as it is here. This is merge sort. Okay, so you get the sorted value, I hope. Yeah, you got the sorted value. So this is how basically the merge sort works. That's how you basically divide and you combine. But if you want to do this in programming, how will you do it? And we'll keep this as a reference. So we can write this section here. So we can compare with this. Now, if you want to write an algorithm for this, first of all, you will get an array, of course. Now, in this array, you will have some values. And we can take the same values which we have here, right? So let's say we have an array with some values here, the same values which we have. And then the next step is you basically need to create a function, let's say merge sort. And this is where you will do the sorting part. So when I say merge sort, the first thing you will do is you will say divide. Now, when you say divide, you have to pass three things. First, you have to pass the array. Then you have to pass the L value, R value, right? And then if you observe, we are dividing, again you're dividing, again you're dividing. So don't you think this is a concept of recursion when you do the same thing multiple times? So we have to do recursion here. So basically here, we have to pass three values, right? So you will pass an array, you will pass the left value and right value for each array. Now, as this will be called multiple times in recursion, every time you have to pass the array, the left and the right. Remember one thing, we are not dividing the array physically, we are dividing it logically. So even if you divide this array, ultimately the values will remain same. Okay, now when I say divide, what it means? The first thing you will do is you have to find the median or the mid value. So I can say mid, but then since this, okay, so let's find mid here. So we got mid is equal to, we know the formula L plus R divided by 2. Now once we got the median, what we're going to do is, once you got the median, you will break down into two parts and you will apply the merge sort in each section. So what I'm saying is, when I'm calling this for the first time, I'm passing the entire array with the L value as 0 and R value as 5, which is the last index. But again, I'm going to call the merge sort by passing different values. So I'm going to pass ARR. Next, I need to pass the first array index value. So the first array here starts from 0 to 2, which is the median. So starting is L, ending is median or middle value or mid value we can say. Again, I will call merge sort for this second array. Again, I have to pass ARR, but this time you have to pass, if you look at the values, we have to pass 3 and 5. Now, where do we have 3? We don't have 3 anywhere. So we can say mid plus 1. So mid is 2. So mid plus 1 is 3. And the ending is right. Okay, so that's how you call the merge sort. We have to remember one more thing. After doing merge sort, which will break it, we have to merge them as well. So when you say merge, you have to pass 4 things here. First, the array, the left value, the mid value, and you have to also pass the right value. Again, we'll see the logic later, but this is the merge you have to pass. But if you call the function by itself, you can see merge sort is calling itself. But don't you think there should be a limit when it should end? So of course, there should be a condition as well. When your left is less than right, then only you do this, otherwise stop. Okay, this is your merge sort. So by doing this, what you will get is you will get the values divided. But where's the concept of merge? We are calling merge, but we are not defined the merge function yet. Now this is where things gets complicated. Not exactly complicated, but it's a lengthy process. So what we need to do is, when you say merge, of course you have to pass all these values here. Now in this merge, what we are going to do. Now basically the first thing is you need to create 2 arrays. So I will not write the exact logic here, but let me just draw something. What we need is, we basically need 2 arrays here. When you say merge, at one time you need 2 arrays. Example, so when we are combining these two, we got 1 array. So at one point you need 2 arrays to combine so that you will get one big array. Same goes here. When you got 2 arrays here, we need to combine them to get a big array. So that means every time I call merge, I need 2 arrays. We'll call them, let's say, left array and right array. Okay, so we got 2 arrays here. The next thing we need to do is we need to copy the elements of the left array and the right array. This is empty at this point. So we need to copy these values from the actual array. Okay. Now, so we need to write a for loop which will copy data from the array. So basically it will copy data from the array and put them in this list. Okay. So maybe I will just write copy values. Again, we'll see the actual logic in the code itself. Okay. Next thing we have to do is, once we have done with the copying part, you will simply use these 2 arrays to combine to get a bigger array. Now, how will you do this? So of course there should be partition here, there should be some values. So what we will do is let's work with the last values here. So we got the last value as 5, 8, 9 and 1, 6, 7. So the logic of combining this is, you will need multiple variables here. You need a variable I, you need a variable j. Now why we need these two variables? One to represent this particular array and one to represent this particular array to iterate. Then we also need a k which will be used for the big array which you're going to create. So from these three values or three values, you're going to create an array of 6, right? So k will be handling this part. Now every time you copy one element, so let's say when you compare 5 and 1 and you know that you're going to copy 1 here, so basically the j value will shift here, right? Because this is done. The same thing goes here. So once you got 1, next time you will get 5 here, then you have to increment this here. So I goes here. And of course, every time you copy element in the bigger array, you will increment the value of k. That's the logic. Okay, so this is how you are going to complete the merge sort. Now, how exactly you have to write the code, that we'll see in the practical video. So I hope merge sort makes sense, where you basically break down the entire array into small chunks and then you combine them to get the sorted values.